first three are just simplify square roots of negative numbers. So as soon as you have a square root of a negative number, you know you can pull out an I, because this is the square root of negative 1 times 9, so that's the same as the square root of 9 times I, which is just 3I. So this is root 8I, which is 2 root 2I. And this last one is root 54I. And root 54 is 9 times 6, so it's 3 root 6I. Okay, next one, example 2, some arithmetic with complex numbers. This one we're going to simplify it first. That's 5I minus 7, and standard form puts the real part first and then the imaginary part, A plus BI. Okay, B is adding to complex numbers, so what we do is we add the real parts. 3 plus 5 is 8, minus 2I plus I is minus I. C, we're subtracting complex numbers, and because we're subtracting, we have to make sure to distribute that minus. So I have 3 minus 2I minus 5 minus I, and then put your like terms together. 3 minus 5 is negative 2, minus 2I minus I is minus 3I. D, we can FOIL it, first times first, outer times outer, etc. Or we can do the rectangle. I like the rectangle. 3 times 5 is 15. Negative 2I times 5 is negative 10I. 3 times I is 3I. And negative 2I times positive I is negative 2I squared. The reason I like this is because your like terms line up on the diagonals, because negative 2I squared is actually negative 2 times negative 1. That's really equal to positive 2. So 15 plus 2 is 17. 3I minus 10I is minus 7I. That's the second part of example 2. The E, you need to divide the complex numbers. It's a lot like rationalizing denominators. We have to multiply by the complex conjugate, which is the same two terms as your denominator, except the sign in between them is opposite. So on the top you have 3 minus 2I times 5 minus I, which is right here. So that's 15 minus 10I over minus 3I times minus 2 times minus I, which is positive 2I squared, 2I squared, which is the same thing as negative 2. So on the top I've got 15 minus 2, which is 13, minus 10 minus 3I is minus 13I squared. Oh no, 13I. And then look what happens to the bottom when you multiply complex conjugates. 5 times 5 is 25. 5 times I is 5I. 5 times negative I is negative 5I. And negative I times positive I is negative I squared. So that's negative 1. That's positive 1. So on the right diagonal, I have 25 plus 1, which is 26. And here I have negative 5I plus 5I. These just cancel out. And I can see that 13 is a common factor on the top. 1 minus I. 26. And 13 goes into 26 twice. So my final answer is 1 minus I over 2. Okay. F, 5 minus 2I all squared. Again, make the rectangle. 5 times 5 is 25. Negative 2i times 5 is negative 10i. 5 times negative 2i is negative 10i. Negative 2i times negative 2i is positive 4i squared, which is the same as negative 4. So what I've got is 25 minus 4, which is 21, minus 20i. And that's in a plus bi form. Negative 4 plus the square root of negative 64, that's the same as negative 4 plus 8i, all squared. So 16, negative 4 times 8i is negative 32i. This is also negative 32i. And here 8i times 8i is 64i squared, which is the same as negative 64. 16 minus 64 is negative 48. And negative 32i minus 32i is negative 64i. And that's the front page of exercises 2.1.